All right, hello. This one's gonna be a little different. This one, I'm just gonna do a live coding example. I'm gonna try to just build chess. Normally, I got a tutorial all laid out with all the code already written. This one, I'm just going in with some PNGs, and we're just gonna try to build from scratch and see how far I can get with ideally a draggable chess game where it has legal moves. See if I can deal with check and actually ending the game or some sort of game controller. Definitely not gonna be online. It's just gonna be like a hot seat type thing. Yeah, let's just start from scratch, see how it goes. I'll try to commentate as I go, and hopefully my keyboard isn't too loud, but yeah, I just got a Flutter new project here, and the only thing I've done so far is I've cropped out the PNGs with the transparent background for all the different pieces here. So I have all the assets set because I was just kind of busy work in Photoshop. All right, so first thing, let's just delete a million of these comments here. I think I might actually just delete the home screen entirely and make my own. Let's call it the home screen still though. Definitely gonna make it a stateful widget, and I think I'm just gonna do everything with set state instead of trying to do some sort of state management pattern. Let's ignore constant linting and stuff for now. Okay, so the hotkey that you're going to see me press a million times is Alt-Enter, and it opens up the context menu. So whenever I get a little menu and I press Alt-Enter, Enter, it's just doing the first thing. So let's make an app bar. And that should be const. Okay, so what should the body be? Probably a column, and then we'll make a chessboard in the middle so that the chessboard is perfectly square. I have chess.com up as an example, so I know from the chess.com app the edge of the board is the very edge of the screen. So let's do that. Don't think it needs to scroll. Okay, so we need like an 8x8 grid of squares that are 1/8 of the screen width. So maybe let's make a getter for how wide we want those. So actually this could be final. Yeah. Oops. Okay, so we have our tile width. So we need an 8x8 grid. So how do we want to make that? Probably list.generate. I'm just trying to think. So we're going to have 8 rows, and each row is going to have 8 children. So let's just build it inline for now and then maybe refactor it into a method later. So we're going to need 8 rows. So let's go list.generate. We need 8 of them, and each one is going to be a row. And then our row also has 8 children. And that is going to be, let's just put a container for now. Let's just put a text in there just so we can see if it's working. Okay, so we got an 8x8 grid, but it's the wrong size. So our width and height both need to be the tile width. Okay, that's looking pretty good. So we're going to need colors. We're going to need 2 different colors. Let's steal the colors from chess.com here. Okay, so this guy is that, so let's make that. So from let's do that. So red, you can see, is 119, 149, 86, and then opacity can just be 100. And then can this be const or what? Yeah, I guess it can. Okay, and then the other color is, how do we even describe that? Light green? Let's call it light green. Okay, light green is 235, 236, 208, and then 100 opacity. Okay, so this is going to need some sort of color for the background. So how should we make our coordinate system? How about this is 0, 0, and then 1, 2, 3, 4, 5, 6, 7. So if the index is even, oh, I guess it depends on both of them for what it is. Okay, so we need the color to depend on both x and y, and we just need it to alternate. So this is, let's rename this to, so this is the y, and this is the x. And let's just start by making it x modulo 2. Oh wait, does this have an is even? Oh, it does. Okay, and now we don't really need a child. So let's see how that looks. Okay, so we got it such that this one is correct, but then every other row needs to alternate instead. Oh. So let's make this into a method so that we can write a little more code. So build tile color, and this actually needs int x and int y. And that needs a return. Oh, why are you there? And this needs a y as well. Okay, so let's make a modifier. So if, let's go int value on x, if y dot is even, then x plus plus, and oops, not x plus plus, value plus plus, and then let's put value here. Okay, sweet. So that did it. So we got ourselves an alternating thing. So basically, we're just alternating based on whether or not y is even now as well. So we got our chessboard, so that looks pretty good. Chess.com has it centered in the screen though, so let's do that as well. Maybe we should make it into a method now as well. So this is actually a list of children. Maybe this should be its own column. That would probably be easier. So let's refactor this. Build board, and then let's put it in its own column, and then what's gonna be at the top and bottom? I guess a player would be if you're actually logged in, but I don't know if we actually need anything in the top or bottom yet. Let's just put spacers for now and see if that censors it. We might replace these spacers with something else later. Okay, so we got our board. Okay, so each piece is going to need to be some sort of image.asset, and it's going to need to be draggable. And then each tile is going to need to be a drag target. And then when we let go, we're going to have to validate whether or not that's a legal move. So maybe right now what we should do is model our chess piece. So let's make a directory IE? EI? IE. Okay, now we know. Okay, and let's make a base class for this. So let's keep that open. So chess piece. Okay, so what does a chess piece have? It needs a file name for its image. Although we could probably build that because I formatted the names nicely. So let's first go string get name. How about that? So that's going to be bishop, knight, whatever. And then I guess let's make an enum for the color, because there's only two possible options. What are you yelling about? Fine. Okay. So we got ourselves piece color. So this needs a. This is actually got to be final, and we got to pass it in. So because we're going to need both of them, so we're going to have a constructor to pass that in. I think I like this stuff to be there, and I like getters to be under there. Okay, so now let's make the file name. So everything's going to need this. So it's just piece color dot split. I'm just going to do this kind of hacky because it's and then underscore actually okay. So enum's toString, go piece color dot the value, and since we know that black is lowercase, then it's going to work. This is a bit fragile and a bit gross. I would normally make an extension on piece color, but this should work just fine for now. Okay, so what else do we need? I guess we're going to need the XY for the current position. So in X, yeah, that sounds good. Okay, so now we're going to have to make some methods to implement later for each piece. So one of them is the legal moves, and then one of them is going to be the legal captures. So a pawn can move 2 or 1 if it's the first. Otherwise, it can move 1, and it can capture diagonally. So that means that moving is based on its position. Because as long as the pawn is on this rank, it can move 2, and the opposite for black. So let's make that method. So maybe we should make a class to hose these coordinates. I'm not sure if that already exists somewhere, but I'll just make one. And actually, now that we have this class, we should probably make. We don't need to split those up. Okay, so we're going to make a method. Well, not make it yet, but we're just going to make the interface for it. So what can it do? It can move to a list of locations, actually. Legal moves. And what do legal moves depend on? It depends on its current location, which is part of this class, so that's fine. Let's for now ignore if a different piece exists there, because you can't move into another piece you can only capture into another piece. Okay, what else does moving depend on? It depends on whether or not you move into check for the king. So the king actually needs to know about every other piece on the board in order for it to know where it can move. So maybe we need to pass in every other piece on the board to this method. That might not be the best way to do this, but I think let's do it. So we need list of chess piece. Let's just call it others. So we need to know about every other chess piece for the king. We also need to know its initial location for the pawn. Knights can jump around. I guess this method, it needs to be constrained to within the board as well. You can't move off the board. So maybe we should filter those off. But I don't really want to filter them every single time. So let's make a method on here as well for whether or not it's valid. I guess this can just be a getter. And then whenever we make a list of moves, we can go like where is valid, and then we'll filter off the ones that are just off the board. So we'll get is valid. So x less than equal to 7 and y less than equal to 7. Because we're going to say 0, 0, and then 7, 7 up here. Maybe I should have used the chess core with the letters, but that's a bit awkward because we don't really use letters for indexes in programming. I think I'm going to keep on where I'm going, just see how it works out. Okay. So x is less than 7 and y is less than 7. So whenever we make a list of legal moves with a piece, we can then filter off the ones that are invalid pretty easily. Okay, so let's try with a piece. What would be the easiest piece to start with? Maybe a knight, because there's 8 distinct locations instead of like a whole path. Actually, let's do a bishop. Let's do a bishop. Okay, so bishop. Okay, and then we're going to implement some stuff. Okay, name is bishop. Okay, legal moves. So bishops can't move through other pieces. So do we need to check and say, well, you can't move if a bishop's here and there's a piece here, you can't move through it either. You could capture. So I think I'm going to make a decision right now and say that a legal move is not a capture. So if we have a bishop here, right, it can move there, it can move there, it can move there, it can move there. But if there's a piece here, it can't move here, it can only capture here. So in the case where there's a bishop here and there's a piece here, it can move in 4 spots. So what we're going to need to do, I guess you need a constructor as well, don't you? Okay, so we have our own location. So I guess you can only move in a diagonal, which is a +1 to y and x, or -1 in a certain direction. So let's think about how we're going to do this. We're going to do this with some sort of list.generate. And each time we generate, we're just going to have to make sure that there isn't a piece in the way. Or maybe we should just check the pieces in the way after. That might be easier. Let's just try to get a diagonal going first. So we can make 2 lists. The list of the ones that go in one diagonal and the list of the ones that goes other diagonal. Okay, so we have our current location. So a diagonal can have a different number of spots. Oh, this is a bit tricky. As long as we make it 8 long from wherever you are, we could then just filter off the locations that aren't valid after. So maybe we should just, from any position, go 8 in each direction and then filter them off. Maybe that's not the cleanest, but I think that's gonna work. So actually I guess we're gonna have 4 of these. We're gonna have up, left. So, and then we're gonna have, well, let's not do it yet. So up and left, we have our current location. And what we're trying to do is make a list of locations. So we're going to have to return a location from here. And we need an X and a Y. So let's change that to I. That looks worse. What have I done? Ugh. Okay, so when we're going up and left, if this is 0, 0, our X is getting minus each time. So this is going to be X minus I. And if we're going up and left, our Y is getting bigger, so it's plus I. And then the X is actually location.x and location.y. Okay, so if this is 0 and we start here, then it's coordinates of 0, 1, 2, 3, 0, 1, 2, 3. And then we go 2, 4. Okay, yeah, that looks good. So this is going to be kind of gross, but I'm just going to do it the long way. Up, right, down, left. So up, up, down, down, and this one's got to be right. So up, left. So up means Y is that way, but right is plus, right is plus. Down is minus. Down is minus. So we should have every combination of plus minus. So we have minus plus, plus plus, minus minus, plus minus. So that should be pretty good. So now, possibilities, or let's just call it locations actually. It's going to be all of those dot where, and that's going to be a location. Okay, so we can clean this up a little bit at least. Okay, and I kind of regret making this have a return statement because it can just be a one-liner thing. And you know what, now that I know how this works, I think we can rewrite it quicker. Okay, so we're gonna have 4, we have minus, plus plus, and then plus, minus. Okay. So those are the 4 directions, the 4 diagonals that we can go, and we're filtering off all the ones that are not on the board. So now the part that might be tricky is that there cannot be an other on the same spot, but there also can't be an other past it. The past it part might be kind of tricky. So once a piece is met, anything after it is invalid. So maybe in here I shouldn't have actually made these arrow functions. Maybe we need to do a bit of logic, because we could just stop the generation and just return null or something, and then filter off the ones that are null. That might have been better. That's unfortunate. maybe I can just Control Z a bunch. Okay, yeah. So, okay, so let's get some bools together. Maybe I should make a method so I only have to do this once. That'd probably be nicer. Yeah, let's do that. Oh my god. There we go. So this can be private. So generate moves on diagonal. Why did you make those? Okay, so this needs a bool is up and bool is, let's do right, because up is positive and right is positive. And this needs all of the other pieces as well, I think, because we need to know if there's something in the way. So let's make a bool piece is in, let's say obstructed. And let's just make it compile for the time being. So diagon. Okay. So we're going to do this 4 times. And we can spread it. And we don't need this anymore. Okay. Okay, so we need true, true, others, and then false, 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 false. Oops. Okay, true, true, false, false. Okay, so those are the 4 combinations. Okay, so now we know which direction to go, and we're going to do something very similar. So we're going to do list.generate, and it's going to be 8, and it's going to be I, and then let's do this, and then final locations. And does generate have a generic type? I can't remember. No, but list does. So let's go list of location was nullable. And then we're going to go, actually we can just return this directly probably. Dot where type location dot where location is valid. So we filter off the ones that are null and then the ones that are invalid. So in here, this is where we got to do our stuff. Why are you? Oh, right. We just got to go to list here. Okay. So now we're going to do pretty much what we were doing before. Let's just filter that. Oh, sorry, reformat that. So each time we go, we got to figure out if there's a piece on the exact same location. So piece on location is equal to okay, others dot, let's do any. We know there should only be one, but let's just do any for now. Any piece dot location is equal to a location that we're going to build. So location doesn't have an equality yet, so we're going to need that. Okay, return other is location and this dot, actually we can just go x and And then I guess this actually doesn't need brackets, does it? Oh. Okay, so now we got the equality, so that check will actually work. Okay, so we need to build the next location in the list. And we are building it based on the starting location. So location is going to be okay, so it's, you know what we could do? Might be a little nice is if we make a getter here. Then we can just go XY directly. Okay, so X, so we need to figure out whether or not we're moving up. So maybe these don't need to be. And dy is up, then it's 1, or else it's -1. And then this is the same, but it is right. So if we're moving right where our location is getting +1, else it's getting negative. So it's x plus dy, y plus dy. Actually, we should make this a variable. We're definitely going to need this. Let's call it position pause. Okay, so this is the new position. Oh, I made a typo. We're usually going x first, then y, so let's make that first as well. Okay, so this is the position in question. So we start at a certain spot, and then we're moving in a certain direction. Next, we got to figure out if there's a piece on this location, because if there is, then we're obstructed. This should be false initially. So if piece is on location, then obstructed is now true. And if we're obstructed, actually we can go return obstructed, null, else the position. Okay, so that generates moves on diagonal, and it might even work. I'm not sure. And we're doing the location is valid check here, so I guess we don't really need to do that there. And we don't need to do anything else here, so we can just return it. Okay, so we're returning the 4 different moves on the 4 different diagonals for the bishop. Okay, that was kind of a pain in the ass, honestly. There's a lot of other pieces. Let's do some UI, that might be more fun. So let's put a bishop on the board somewhere and see if we can get a bishop on the board and make it draggable. Draggable anywhere first, and then we'll try to make it draggable to a legal move. And then maybe for bonus points, we'll make it so we highlight the legal moves. So let's go back to our home screen. You know, I just realized that this is actually generating it with y being the 0 up here. So if I use y in my location class, that's going to be broken. X is fine, but y is reversed. That might work. Oh, that flipped my color. Which means I need to just flip it back. Yeah. Okay, cool. So I guess we need like a game coordinator kind of class too to keep track of whose turn it is and all sorts of stuff. So game coordinator. Okay, so what are we gonna do? Let's have two lists of pieces. I think it can be final, yeah. White pieces and then black pieces, and we can initialize that with where all the pieces are supposed to be, and then maybe we can try to display the bishop with this guy. So this is going to need a normal constructor as well. What else do we need for a new game? I don't think it's needs anything else. We do need to keep track of whose turn it is. Let's change this to player color. And we're gonna need a player color. How do we name whose turn it is? Current turn, how about that? And that starts off as white, so that can be player color.white. Okay, so let's make our new game constructor here. So we're gonna have to return one of these guys, and we're going to need to make two lists of pieces. So let's just do it kind of quick and dirty for now. So we're gonna need, let's put in the bishops. Oh, maybe we should make a factory constructor for initial location. Actually, no, that should go on here. Yeah. Initial location is something that we definitely need. Oh, wait. But pieces can have more than one initial location, so that doesn't actually work. That needs to be final. Wait, what's the difference between initial location and location? You know what? No, this was a bad idea. Let's just hard code it in and see what happens. So we're gonna need a bishop, and first is white pieces, so it's player color.white, and then its location. We'll just hard code, and we're gonna have two of them. We're gonna have two of them for them as well. These need commas. Okay, so it's 0, 1, 2, and then 0 for white. And then it's going to be 7 up here. And I guess it's going to be 2 as well because they're in the same columns. So 0, 1, 2, 3, 4, 5. Okay, cool. So we got our game coordinator new game. Let's instantiate that in here. Okay, cool. And then let's get should we get a getter to get all of the pieces in the whole game? So we can just iterate through all of them. Probably, right? Get. Do the same here, coordinator dot pieces. We'll probably use that a lot, so it's nice to have another getter just to cut down on how many times we're calling coordinator dot. Okay, so we're gonna have to map every piece onto the screen to display it. So let's first just display it, and then we'll think about dragging them. Okay, so build board. This is like a background. And we've made a bunch of different containers. So should we stack the pieces on top? Or is this just a background? Let's look at the draggable and see what we need to do here. So I'm going to draggable. Data is the value this draggable stores. Okay, so I guess we'd have a draggable of chess piece. And then feedback is the actual, that could just be the same. Child when dragging. So that would be empty, a container, I guess, for me. And then we need a drag target. So this is a row. So upon letting go, we're going to need to call a set state and move that one piece. So this guy just gets his position. Yeah, okay. So let's think. I could stack it onto this container. I could make it the child of this container. And then look up which piece, if any, has that location. That sounds like the best idea. Let's do that. Okay, so child. So this is going to be an asset image. We're gonna have to figure out the name, the piece though. Actually, let's just make this a method right away. So this is gonna definitely need x and y. Okay, so let's build this method. It's gonna be a nullable widget because there might not be a chess piece that lives here. And we don't need these to be dynamic. These can be a full-on ints. Okay, so first we need to figure out if a piece lives there, but that sounds like logic that the coordinator can figure out. Piece is on tile. Pieces. Oh, you know what? No, it would be much better to return the actual piece. So it would make it nullable. Piece of tile. Pieces dot firstware p dot x and p dot y is equal to y. Yeah. Okay, so what did I name it? Coordinator dot piece of tile xy. So if piece is not null, we're going to return image.asset. I think I forgot to put the extension on. Yeah. It's going to be .png. I think they're all PNGs. They are. Okay. So this is piece dot file name. This is no, just one. Wait, what? Okay, piece dot file name. And something crashed. No element. Oh. or null. Let's try that again. Unable to load asset black bishop underscore png. Black bishop.png. So it looks fine. So we got assets. Pubspec.yaml, I got my assets. You have 2 and then 1. What the fuck? Oh, I'm so dumb. Do I just need to put dot assets in the... Do I just need assets slash in there? I might need the dot slash as well. We'll see. Might not matter. I'm pretty sure that's what I've missed. That's pretty silly. Ah, oh, beautiful. Okay, they're a little too big, but that's pretty good. Okay, so so we got the tile width here. So do you have a height? Yeah, you got a scale and a height and a width. Okay, so let's go. Height is, I mean, we should just put a, no, let's just do this. So tile width times, let's do 80%, and height is the same. So or did that do literally nothing? What? Image.asset is really weird. Sometimes you'll give it a size and it literally won't do what you tell it to. Put it in a container. Yeah, that's so weird. I don't know why that is. I don't know if it's a bug in the framework, but image.asset does not care what you give it unless it's in a container and it's aligned. I don't know why, but that's okay. That looks a little nicer, doesn't it? Okay, so now we need to be draggable. So let's try that draggable class. I guess we want the entire container to be draggable. And what do you need? Feedback. I don't know what feedback is. We'll look in a sec. This is of type chess piece. Should help us later. Feedback is a widget. Widgets show under the pointer. Okay, so maybe we should actually put this as a variable, because that's going to be both of these things. And then, okay, so let's save it. So we got our draggy boy. Oh, I like that. I've never used draggable. Okay, let's go back here. So we want it to be invisible when you're. So child when dragging. We don't want a child when dragging at all. If we put this as null, does it respect that, or does it? No, we're gonna need a. We're gonna need a shrinky boy for that. Yeah. Okay. So that's pretty sick. Okay, so now we're gonna need on. What the hell is the difference between drag completed and drag end? What do they do in the docs? Completed is end. What's the difference between completed and end? On accept. int data. I don't know. Let's just start debugging and see what happens. It says details. Okay, so let's see what it prints here. I actually don't really know. On drag end, instance of drag details. Well, what does on drag completed do? Let's... Oh, dropped and accepted. Okay, so I don't think we actually do need to use that. Actually, we might not need to use either of these because the target, it sounds like the one that accepts it or not. So let's make some drag targets here. So chess pieces, where did we put that? These are the childs. So presumably this can also be a drag target even if it has a drag child. Let's try it. So you're a drag target of type chess piece. And you need, child is not defined. It needs a builder. Fine. What is your builder? Drag target builder. Candidate data, rejected data. I don't know what the hell that is. Reject. Okay, I kind of want to put this into a method now. This is getting a little bit too nested here. So build drag target. That's a good name. Okay, so we have a builder, list of chess piece, and a list of dynamic. Okay, I don't know what pieces that's referring to. Okay, so on accept with details. On will accept. Let's see what some of these do. Because I don't necessarily always want to accept it. I gotta check if it's illegal. So on accept takes in a piece. Okay, so let's print that. Actually don't have a toString on chess piece. That might actually be useful as well. Oh, null check operator is on a null valuable null value. I don't get a stack trace. Oh wait, it moved. Why did you move? What even crashed? I don't really know. Drag target crashed. Avatar.data is T on did drop. Sure. Okay, what is on will accept? Call to determine whether this widget is interested in receiving a given piece of data dragged over this target. That is absolutely what we want to do to check the whether or not it's allowed. Okay, so on will accept needs to return a bool. So let's just return true for now. And then okay, let's I still don't know what crashed there though. Did drop. Drag target state. No stack trace, why? Might need to Google that as well. Because then it can't be used anymore. Called when an acceptable piece of data was dropped. Wait, is it just because my print statement and it's... Is this nullable? No. Is this nullable? That's nullable. Okay, well, let's just keep coding and see if I can fix that crash later. Whoops, sorry. Okay, so return piece dot legal moves. Maybe we should make a getter as well for bool can move to can move to XY. Yeah, let's do that. Okay, so piece dot can move to XY others. It could be null. Why would it ever be null? Presumably we don't want to accept a null piece, but I don't really know why it would ever be null. Others. So this is just pieces. Okay. Let's put a breakpoint there. Let's put a breakpoint in a couple places. Okay. So we go here. Actually, I'm gonna put one here as well. Oh, now you're null. Oh, wait. What? I don't know why that's doing that. Okay, so now it's not crashing. I think actually one of my print statements was crashing. Is piece ever not null? It's not accepting it. It's kind of weird. Null, 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 null. And I let go and nothing is triggered. It's kind of weird. Let's look at the thing again. Okay, so the draggable only has widgets, it has no methods. Accepted, rejected, maybe I'm not using those correctly. Accepted data plus equals data. Am I misunderstanding what this widget even does? Why would it be a list? Accepted data plus equals data. So the accepted and rejected are actually not used in this. It's just when there is an accept, we get a callback with the one that it was accepted. But on it, they don't have a implementation for on will accept. Let's just comment this out for now and see. Okay, so that can't be null there. Let's try this again. Presumably if you don't pass this, it just always accepts. I don't understand why this is throwing. My breakpoint is not getting hit either. Is it because it's a child and it's not stacked on? Does that make it kind of weird? Maybe. Maybe? Drag target has a builder and a child. Let's make this a stack instead, maybe. It's a bit weird though, having all these stacks everywhere. Let's just try it. And then you no longer have a child. So it draws this first and then the other one on top. So this has got to go at the bottom. And widget cannot be null. Okay, so let's go. This isn't even the same one that I'm using, so I don't know if it's useful. Okay, avatar.data is null. Drag avatar. Okay, so we got draggable chess piece. Data. Oh my god, is that what I'm missing? Data is the piece? But data can be null. That doesn't make a lot of sense, although I definitely want that anyways. Okay, that was the issue, so I want to go back from this stack. I don't like this stack. I might just control Z until. I feel like data should be required. That's a little confusing. Required even if it's null. Because now we got a bishop at location 2-0. Okay, this is looking better. Okay, so Let's now see if it ever gets to here. Okay, yeah, now it's getting piece can move to. Let's make some more print statements here. So piece can move to XY, and then accept, or whoops, okay, accept can or cannot. You need a quote, and you need a bracket. And gonna return that. Okay. Piece can move to 3-1. That is true. Cannot move to 2-1. Can move to 1-1. Okay, this is awesome. So let's update the movement. So when we accept it, all we gotta do is go set state and call some method that I haven't written yet, I guess. So let's go to game coordinator and let's go to void move piece int x and y piece. Okay, so you have to replace it in the list. Okay, so maybe is separating these actually that useful? Well, okay, so if piece dot, oh, that doesn't have a type. Player color. Okay, so int I is white pieces dot index of piece, and then white pieces I is assigned. We're going to need another method here, so can move to. Let's go chess piece move to. Should this just not be final? Is that easier? I don't really like mutating things like that directly. Yeah, it's okay. Okay, so do we even need to do this then? Let's just do it even dirtier. It should work if we just go, I know we have a game coordinator moving pieces, but just to get it to work, let's try this. So piece dot x equals x, piece dot y equals y. Oh, right, piece dot location gets hit. Oh, it worked. Sick. Okay, so let's get the bishops in a place where they conflict with each other. Oh, my thing is bugged for whether, oh wait, no. Okay, so it can move there, move there, move there. Okay, so we're not supposed to be able to move here. Cannot move to 3-5, good. Can you move here? No. Can you move here? No. Okay. Can you move here? No. 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 Okay, it looked like there was a bug. Oh yeah, it doesn't like there. Why can't you move there? Cannot move to 3-2. Cannot move to 2-2. Why? I think my check for whether a piece is in the way must be screwed up somehow. Let's debug that. Okay, so others. Okay, so let's just read this and make sure that things are right. Maybe my coordinate system's all backwards actually. You know what might help is if we child build chess piece XY. Okay, that'll help for debugging. So looks like my coordinate system is how I intended it. So that's good. Okay, so generate moves on diagonal is up. If we're going up, we're going up by 1. Yeah. If we're going down, we're going down by 1. Yeah. If we're going right, we're going up by 1. Yeah. If we're going left, we're going down by 1. Yeah. Okay, so the resulting location for this guy can move to 3-3. Cannot move to 2-2. Okay. Okay, so let's just print here. There's a piece on 4-4. Yeah, that's itself. That's fine. Oh, it moved. Okay. It can't move. Oh, now it can. Oh, interesting. Okay, so it can't move there. Okay, so let's do this again. So we go up here. Cannot move to 4-4. Doesn't say there's a piece there. Cannot move to 4-4. Does not log that there's a piece on that location. Interesting. True, true, false, true, true, false, false, false. So we got all 4 diagonals. Did I screw up these X or Y getters somehow? X, X, Y, Y. That's fine. Let's see what's going on here. Although that's okay. So So we're going up and right. So let's debug this guy here. Can't spread that apparently. Okay, so it makes 7 locations. So it makes 3, 3, 3, 3, 3, 3, 3, 3. Oh. So I forgot to multiply it by the number of tiles away it is. Okay, so now let's see. Okay, so I stop at the breakpoint. Let's evaluate the same thing here. Now we have nothing. Wait, I did this totally wrong. What am I doing here? So isn't that time size? Wait, let me go back. So this would be 0, 1, 2, 3. Doesn't like any move now. Okay, so let's think about this. So this is gonna be a number from 0 to 7, or 0 to -7. I wonder if there's an issue with the is valid. X less than or equal to 7, and y is less than or equal to 7. Yeah, that looks fine. Okay, well, we know that this should never get hit, right? Because it's not obstructed. So let's see if that gets hit. It's not getting hit. Something about this. Let's see if I'm iterating over the positions correctly at all. Instance of location. Okay, I gotta go to string here. Okay, so we're currently on, okay, wait, let's just clear all. Okay, so 2, 2 is what we're on. 3, 3, 4, 4, 5, 5, 6, 6, up to 9, 9 off the screen. And then 3, 1. All the way to -5. There's a piece on 2, 2. Okay, that's itself, so I guess that's fine. Okay, wait, so three, 1, 4, 0, so that's that diagonal, that looks fine. Then 1, 3, 0, 4 off the screen. That looks fine. Okay. Okay, so those look fine. Let's just, don't think I need that anymore. Okay, so it's obstructed, true. Oh, it obstructs itself. Oh. We should just start this at 1. Or is that easier? No. Let's just leave it how I had it and just make sure it's not the same. And location. There we go. I don't like this name anymore. Let's name this destination. Okay. So once it obstructed itself, it could not move anywhere ever. Nice. All right. I like that. Okay, let's get rid of some of these prints here. Cool, so this is just can move to. So maybe we should just end on captures for the one piece and leave it there. I think I can get rid of this crap everywhere too. Okay. So let's do captures. So chess piece has can move to. We're going to need to know if it can capture. Man, this must be really complicated with checks, because can move to, if it opened up a discovered check, that would be really hard to figure out. So you'd need to analyze the board for checks in the destination every single time you move before you're allowed to do it. I think that's how I would do that. Anyways, let's go and do pretty much the same thing. Can capture. Wait, what am I doing? Actually, let's instead go legal captures. You know what? Putting the word legal there is kind of implied. Better. Okay, so now bishop's not compiling because it needs to get this guy. Okay, so this is going to be really similar. So we're going to have to look at the moves and find out the first one on the diagonal, because if this guy's here and there's a bishop here, it can capture the bishop, but it can't capture this guy. And that's going to be different for different pieces, right? Because if it's a knight, you know, it could capture both of these squares if it was here. So we're going to have to do something very similar, which is generate captures on diagonal, I think. Let's just copy and paste this guy and just do pretty much the same thing. Generate captures on diagonal. And we're going to need to here. So that's going to be captures. And let's put it back up underneath this guy. And I like little tiny things to be right at the top of the class, like the name. Okay. So we need generate captures on diagonal, which is currently the exact same as a move. So let's rename this to has found capture. So we can keep the destination logic. We can keep the piece logic. So if there's a piece on location, we found the capture. And here we can return that destination. And here for bishop, I guess we can just skip everything. We can short circuit if has found capture, return. No. Actually, wait, could we do the same thing here? Yeah, we could. That would probably be a little easier to read. Hopefully I didn't break that in the process of doing that, but okay, so this is similar, but if we find a piece on the location and it's not where we currently are, others isn't actually a very good name. This is all pieces. I think that's because it includes the current piece. Okay. So if there's a piece there and it's not our current location, we found a capture. We return that one place on that one diagonal. We can only have one capture per diagonal, or 0. And I guess we might as well still check if it's valid. But that looks good. Okay. Okay, so let's go back to our screen here. See if that worked. Okay, so piece is null. Okay, on will accept. So the highest priority thing, I guess it doesn't matter which one you handle first. So let's go. Can move to there. And then can capture this piece. Oh, I need a similar. I do need this, I think. So can capture, and this is captures.contains. Okay. So now we'll accept it if it can conflict. So I wonder what happens if I just put it on top. Yeah. So it's still there underneath. So we just got to get rid of it. So in on accept, we got to just figure out if it's a capture or if it's a move. So I guess on accept we're already assuming that it's gonna work. So we don't need to check anything then. Let's just find the piece. Captured piece is assigned pieces.where all right, do I have a yeah, okay. Okay, so if captured piece I'm kind of wishing I put this pieces thing in one array because I have to remove it from the source of truth. And I don't know what color it is, and I have to check every single time. I'm just going to go back on that right now. And you can make getters to get the ones of a certain color instead. That might be easier. Okay, so that's all I needed to do there. Let's get rid of this too, because it makes it look like you can set state there, but you... Oh wait, would it pass by reference? Actually, that might work. Okay, so if captured piece is not equal to null, let's print captured piece captured, and we need to go pieces dot remove captured piece to get it out of the game. See if that worked. Oh, what are you mad about now? Oh, when you change that sort of thing, you can't hot reload, you gotta restart. Are you going or what? Okay, I'm just gonna restart. I don't know why it's taking so long. If the capture works, I might just leave it at that and then, you know, leave the rest of the chess game as a to-do. It's already been a couple hours. But it's going pretty good, I think. You know, it's chess with bishops. Okay, so we gotta set up a capture. So you go here, you go here. Captured. Sick. Love it. All right, that made me pretty happy. Okay, that was pretty fun. Hope you can see how the rest of the game might go. I think checks would be really complicated. I think discovered checks would be really complicated for the legal moves. I think you need to check if there's any checks every single time there's any sort of change, because it would make it illegal depending on whose turn it was, because you can't put yourself in check, but you could put the other opponent in check. I think checks would be one of the hardest things for the chess game. We'd also definitely want to save the history of the moves for in the chess notation so that we could save that somewhere, and also we'd want to be able to step through the moves via that, you know, take in that comma separated like chess notation and build the game from there. Yeah, this is pretty fun. I guess if you guys want me to keep working on this, I could keep going, but pretty tired for now, so I'm gonna leave it at that. Yeah, hope you enjoyed.